Hi everyone, welcome to No More YAML Engineering with CDKs. My name is Elad and I'm a principal software engineer in AWS Developer Tools. In the past 3 years, I've been technically leading the CDK project, and I'm excited to talk to you today about CDKs, which is this new project we just launched in alpha in May. So what is CDK for Kubernetes, or CDKs? It's a software development framework for defining Kubernetes applications using familiar programming languages. CDK's apps synthesize into standard YAML manifests, which then can be applied to any Kubernetes cluster. So what we're going to do today, we're going to talk a little bit about YAML and what's wrong with YAML. Why isn't YAML the best thing since sliced bread? We're going to talk what is CDK's approach to solving this. The majority of the time we're going to spend doing a demo. This is where we're here. It's a software development framework. We're going to show some code. And then we're going to come back, do a little recap, and send you off with a bunch of links and things to follow up on if you're interested. So thanks for coming. What's wrong with YAML? So YAML or JSON are very useful formats for describing the desired state of a system. And they actually become the industry standard for this type of work. You apply your manifest, your YAML manifest or your JSON manifest to a system, to Kubernetes, for example, and the system reconciles its state to meet your definition. And we love this approach. We think it's a fundamental piece in any strong DevOps workflow. It enables the entire system to be recreated and updated from a source definition, and we really want to preserve this property. The problem is that YAML does not scale as the application grows. It is very hard to model complex relationships in YAML. Even simple things like loops and conditional statements are impossible to express. Definitions in YAML are normally loosely coupled, which means that their relationship can easily break and only discovered at runtime. They don't have a composition model where you can combine multiple YAMLs to form higher level concepts and share them. And so what happens is that the Kubernetes ecosystem has many projects around this space of application definitions, and they deal with these limitations in a variety of ways. Kustomize, Helm, KSONNet, all of these are great tools, and some people love to use them, but fundamentally they still keep YAML or some kind of a templating language above YAML as the center of the developer experience. And so CDKs tries to approach these problems by leveraging general purpose programming languages, which are surprisingly very good at solving all of these problems, because in the last 50 years, the programming language space has matured into an incredibly efficient practice. We can now be extremely productive using intelligent IDEs, rich object-oriented modeling primitives. We have great ways to express logics and structure and connections and types. We have great ways for creating and publishing abstractions, collaborating on code. And so this is CDKs. It basically attempts to take the best of both worlds. You define your application using a powerful programming language, but you eventually get the desired state as standard YAML, which can be applied to any cluster and integrate with any existing workflow that you already have. Okay, so time for a demo. I'm going to show you a little bit what it means to use CDKs. We're going to build a little application, and then we're going to come back and do a recap. Okay guys, so let's see a little demo of CDKs. I created a new CDKs project here. It's actually pretty simple to create one. You can use CDKs init, which gives you a bunch of predefined templates for simple projects in Java and Python and TypeScript, and soon we're going to support more languages. A CDKs project is structured as a tree of constructs. We talked a little bit about constructs. Those are the basic building blocks of CDK applications, and they form a tree. So at the root of the tree, you can find an app construct, and then within the app construct, you can see that we are adding a chart. Charts are a primitive in CDKs that synthesize into a single Kubernetes manifest. And so you can create multiple instances of a chart, and those will synthesize into multiple manifests. For example, you can create a chart that represents your production environment and your integration environment. And those would be two different manifests, and you can apply them separately to your cluster. And then within this chart, we can add resources. So let's just add, a pod, right? Like this Kubernetes example. So we have to start with a pod. And you can see that as I created the pod here, my editor automatically imported pod from imports k8s. And we'll see a little bit more what imports are, but for all intents and purposes, this is a class that represents the Kubernetes pod API object. And you can see that it also has type definitions, it has documentation strings. For example, I can define my pod here, and then if I look, the IDE tells me, okay, I need metadata and I need spec. Both of them are optional in this case. And so if I go to the spec and it says, oh, well, container is required because you have to specify containers for a pod. And so all of that information is automatically imported from the Kubernetes API definitions, the open API definitions for the core Kubernetes API. So let's define a little pod here. I guess we'll start with like a simple hello world type example. So my image is going to be Alpine. And for command, I'm going to do something like this maybe. Pretty straightforward. So you saw the initial experience. I think the benefits obviously are that your IDE gives you full support. You get all the documentation and code completion, and obviously it's support in all the languages. Like if you use Java, you get all that stuff from your Java IDE or Python IDEs or .NET IDEs, etc. But one thing to remember, and we'll talk about this at the end a little bit, is that this pod is basically one-to-one representation of the Kubernetes API object. There's no higher level API here. And so I actually need to specify everything very, very similarly to how I would specify it in YAML, only that now I get this typing aspect, which is absolutely valuable, and there's obviously more values to it later. Okay, so now what do I do with this? I do what we call synthesis. I take my application, I execute it, and the result of my execution is a Kubernetes manifest. So the way you synthesize CDK's applications is by calling CDK's synth, and then you'll see that I have a dist directory here, and my dist directory contains my little manifest. And you see it's very straightforward. The only thing that's kind of interesting might be this name. You notice that I didn't have to specify name, which is something that you do have to specify when you define Kubernetes manifests. CDK's automatically allocated a name for me based on the location of this construct in the construct tree. And that's actually a super important part of the power of constructs and the power of this type of programming model, because it enables composition. I didn't have to specify a name, but I did have to specify a local name for my pod. And you can see that name over here. Had I changed this to hello, for example, and synthesized again, you see that I got a different name here. And this hash suffix makes it unique, so we can create a user-friendly part and a unique part. And we'll see a little bit more how these names work in the future. But the important thing to remember is that the name of the pod, unless I actually specify it through my metadata, which I can totally do, right? I can totally do my pod, and I can totally do this, and then I need to do that again, and then I can see that the name, I can totally control this name. But I actually don't want to control this name. I want Kubernetes CDK to automatically do that for me. Okay, so now I have my manifest, and the way I basically apply my manifest is just kubectl apply. And we're going to use this command quite a lot, synth and apply. So basically synthesize my manifest and apply it to the cluster. And if I do this, I should be able to see my hello pod here. Let's see, logs, hello CDKs. So we've got our first pod. Simple example. Let's delete our little pod and also delete it from here. And then we can move on to the next thing that I wanted to show you. Okay, so pods, obviously you can see that we have pods here. If I look at my imports, just here, you'll see all of the API surface, the core API surface of Kubernetes, exactly as I said, one-to-one with the API surface of, with the APIs that you can see here. How about custom resources, right? Kubernetes is very powerful as it allows extensibility through custom resources. And the nice thing about custom resources is to play as first-class citizens in Kubernetes manifest. So you can define something like a Redis cluster, for example, in your Kubernetes manifest as if you defined a pod. And so CDK takes this approach and basically treats API objects that come from the core Kubernetes API and custom resources in the same way. And in order to be able to use custom resources, first we need to import those custom resources as classes into my application. And for that, I'm going to use this command called CDK import. It's a pretty powerful command, and basically it's designed to allow you to take a Kubernetes API specification, such as the core API or custom resource definitions, and produce classes from them. And that's why you've seen the K8s file over here in the, sorry, I'm looking at the wrong file, in the imports directory. And so this K8s file is actually automatically generated when I created the project. I can obviously import a different version of the K8s API. But now let's try and import a custom resource. And so I actually have a custom resource already installed in my cluster for Redis. This is one of probably 5 different operators for Redis that this one I really like. And I can actually output the custom resource definition here, right? Like if I do OJSON, this is the entire spec of the custom resource definition. And so what I can do here is I can do import from stdin. And you'll see that K8s, the CLI, automatically identified this as a custom resource. You can also see that it added a directory here with my import. And so now I can bring that guy in. Cool. So now I have a Redis class. Let's see what it gives me. Redis. I'll just call it Redis again. And you'll see that my ID tells me that I need a spec, because the custom resource definition, the JSON schema in the custom resource definition explicitly states that I need a spec, so that's fine. And then if I specify a spec, it says, okay, you need replicas and you need Redis. So let's go. Replicas 3. And you can see that replicas, number of replicas, the Redis failover cluster, all of this information came from the custom resource definition and automatically brought in or imported into my programming, into my project. And then the Redis thing here takes an image. Obviously it takes more stuff, right? Like I can specify other things, but I want the minimum, so I'm just gonna specify only the defaults. And for the image, I'm gonna use Redis 5-Alpine, which is a standard Redis image. Okay, I guess we can see what, let's synth first, see how this synthesis output looks like. Looks okay, looks straightforward. And then we're gonna run our little magic command here. Synth and apply. And while this is applying, I can see that I'm starting to see this. So now I see that I actually have 3 Redis. Oh, this one's from an old, from an old test that I ran. But this one, basically, this is the one that I have here. So you see that I even have I have a master, I have headless, I have slave. The 3 replicas that we talked about are defined over here. You see 1, 2, 3. Perfect. This is exactly what I want. Just let's give this container. Okay, all of them are running. And so let's give it a little try. I'm going to do a port forward for the master service. And 6379 is Redis's. And now if I add another console here, and I do Redis CLI, yeah, cool. So I can do something like set foo bar, get foo bar. This is Redis, right? Okay, so I'm actually gonna leave this little port forward here in the background, and I'm gonna add something over here. Okay, let's exit here. Let's play with this a little bit, okay? I'm just gonna create another console, and the port forwarding is still running, so I can do the Redis CLI stuff here. So what I want to do is I'm going to create a list, a Redis list, and then I'm going to add an item to that list. So let's just create a list by adding an item, L push, we'll call it pings, and then this is the first ping. First ping. And then if I want to see this list, I can do something like this, right? So I get like all the items in the list. Now let's run this in the loop. So let's do while do Redis CLI L range ping 0 -1 sleep 1 done. So this is going to basically pull my Redis cluster and show me what I have in this list. Now I'm going to open another tab here, and let's try and actually like write something from a pod in my cluster, right? Like that was something that I did from my development machine. So I'm going to go back and I'm going to create a pod here. Call it Pinger for lack of a more creative name. And my container is going to be based on the Redis image. Let me see, I have the name of it. Good Smile Duck. Redis CLI. And then the command that I want to run is user local bin Redis CLI. And then I actually need to specify a host. Like how could I find the Redis stuff? And the interesting thing is that the host is actually a derivative of the name that was allocated by the by the operator, by the Redis operator. And it's based off of the name of this little object. So what I'm going to do is I'm actually going to pick up that name, and basically the operator is doing this. So it's basically Redis dash the name dash master, and that's what the customer. This is what the operator is doing. So this is how I know what the host of the Redis master is. And then my command, let's do it like this so it's easier to read. My command would be L push pings hello again, I guess. So basically I'm just gonna add another item to this list. Okay, synth and apply. Hey, this actually worked. Okay, so you see that now we have 2 items in the list. Actually, it seems like we have 2 hello agains and 1 first ping, which is pretty interesting. I wonder if that's an interesting. Is that a restart? Hello, pinger. Restarting failed container. Yeah, so you see that the container is restarting. It's just on the container option. It's not the pod, the entire pod. And you can see that I get these hello agains coming into my. Okay, I'm going to delete this little pod just so that it doesn't. Hello pinger. I think it's going to take a little while because I didn't specify the exit code properly. Okay, so now last thing I want to do, I actually want to create like 10 of those pingers and you know, send them all to my database. And before I do that, I want to show you this little cool idea that's actually very, very fundamental to how the CDK works, and it's a big enabler for abstraction and for organizing your project in various ways. And that's the idea of creating your own custom constructs. And so you saw that basically I have this chart here, which is a construct, and Redis is actually a construct, and the pod is a construct. And constructs are really easy to create. They're designed to be very easy to create. So what I can do is I can actually create a class that extends construct. The constructor always accepts these two parameters. And this is basically the minimum definition of a construct. And you'll see that the base idea behind a construct is this concept of a scope, a named scope. Scope and ID create this named scope. And everything that I define within this construct is unique within that scope, needs to be unique within that scope. And then I can compose these higher level ideas together. And that's how these automatically generated names work. Had I specified explicit names and I composed two things together, those explicit names would clash. And if you use Helm, you've probably ran into a situation where you wanted to deploy multiple instances of a Helm chart and started getting clashes between resource names, because those weren't designed well to allow that. And so CDK gives you a very, very fundamental way to do that, and that's using these constructs. And so what I'm going to do is I'm going to basically take this little pod and I'm going to put it inside my pinger. And you see that when I create the pod, I specify the scope of the pod is always this. Like whenever you define a construct in CDK, the scope is always going to be this, because that's what creates this locality, right? I don't actually have to specify anything about the parent scope. Okay, so now I'll just call this pod, I guess. And you see that I need the Redis name here. And I also want this, this string probably to be an option. So what I'm going to do is, what we usually do is something like this. And so we go Redis, and I actually can accept a Redis object. I don't need to accept a Redis name. I can accept the entire object, which is pretty powerful. And then let's see, message. And then I'm going to add these here. Pinger options. And then here, I'm going to replace this with ops Redis name. And here, I'm going to replace this with ops message. And now, I'm going to basically do something like this, right? This is a regular programming language. By the way, I didn't say this is TypeScript, and we support other languages like Python, Java, .NET, Go is in the works. And this is a pretty powerful technology that drives this language support. It's called JSII. You can find more information about that obviously online. But the idea is that it allows us to write all of these this entire framework and all of these capabilities once and vend them to multiple programming languages using this binding technology that we have. It's pretty cute. Okay, so now I'm going to do a new pinger. Now I'm going to need to do pinger I, right? Because I need this name to be unique within the scope. So I have to actually add some unique aspect to it. And you see that I get the exact same experience that I got with Redis and with the pod. Like all constructs are created equal. There's no difference between a pod and a Redis cluster and a chart and my own constructs that I created. Okay, so it says I need Redis and message. So Redis is going to be this guy, and message is going to be hello from pod number I guess. Okay, cool. Synth and apply. So first of all, you can see that it automatically created these 5 pods for me inside my manifest. And you can also see that these pods are starting to ping back to my Redis cluster. I think this is an initial demonstration of like the basic building blocks of CDKs. And what we've done with CDKs is that we focused on the foundation. We focused on the basic framework, these constructs, and the import capability, the ability to basically bring in the Kubernetes APIs, bring in custom resources, definitions, and even at this layer, you already get tremendous value from this library because it elevates your experience into a programming language space. And programming languages are very powerful. You can create abstractions and model things and create rich APIs. And as we were doing this, we realized that we can also create abstractions, right? We can also vend abstractions for Kubernetes based on this model. And so last week, we actually announced an alpha version of another child project of the CDK project. We call it CDK Plus. And I want to give you a sneak peek of what it is. So this is the CDK website. It's a good entry point if you're looking to get started. And CDK Plus is currently still on GitHub. It's very, very initial. So it's we're basically shouting out to like contributors and early adopters who are interested in this higher level abstraction for Kubernetes. But it's already usable and useful. And we've actually created we actually have a real world application that we use this project with that drives the search component of the construct catalog. I'm not going to go into that. We actually have a blog post that describes this entire story, but you can actually see like an actual usage in the real world application with CDK Plus. And so the idea of CDK Plus is that instead of defining your Kubernetes resources at the level of detail required in your manifest, we've created a higher level API that's intent-based. And we like this concept of intent-based or intent-driven, where instead of actually specifying all the data, you specify what you want. You specify, I want to be able to create a config map and add a directory to it, which is very similar to what you can do with kubectl, create a config map with a directory. But this is actually fully declarative because it synthesizes into a Kubernetes manifest. It's not a one-off command that you shove into your cluster. And so you can do something like, let's create a config map and add a directory to it. And then let's create a volume from this config map. And you see this API is richer and higher level from the low-level Kubernetes API. And it also is very strongly typed, right? I can't pass in anything here besides a config map, right? So when I do k+.volume.from, I can see all the options of where I can create volumes from and pass in the exact object, and it'll automatically, resolve it and dereference it. And then you can see that there is a very rich container API that allows me to do something like mount, right? I can say container.mount application path from an application volume, and it'll take care of adding the mount volume to your container. It'll also take care of automatically specifying the volume inside your pod specification. You can also see that I can create a deployment. And so here, again, it's a richer API. I specify the replicas, the template for my pod, and I can also do something like expose, which will take the deployment and expose it as a service, which is, again, similar to how you can use expose in kubectl, but it's fully declarative. It's fully based on the desire. It fully creates the desired state. You can see the output of this little thing here. So this is what you would have to do manually, right? And again, it's not horrible, but this guided experience with your IDE supporting you with strong typing, compile time checks, is extremely productive. And we feel it's appealing to a larger audience for Kubernetes, and hopefully makes it easier to use Kubernetes. Okay, so this is what I wanted to show you. I hope that we're going to do another session on CDK Plus soon and show off some of the higher level APIs that we have there. But that's all for now. Thanks. So this is what we had today for this demo. There's definitely tons to do. There are some examples in our repo that you can check out. There's already some community content that you can find on the internet. So let's do a little recap of what is the benefits of CDKs. So you define your applications using familiar programming languages. As I said, today we support TypeScript, JavaScript, Python. Java is just very close. .NET and Go are coming up. We actually use this pretty interesting technology that we developed for the AWS CDK called JSII. And if you're interested, you can check that out too. Then you compose and share a usable component using code libraries. So you can take Kubernetes components, produce code libraries from them, and just share them as regular code, which gives you a huge superpower, being able to like use CDKs to standardize how you define Kubernetes applications. Lastly, CDKs integrates perfectly with any existing Kubernetes workflow, like a GitOps workflow, because it comes before the existing workflow, right? Like as if you were writing these YAMLs by hand, you can just use CDKs to synthesize them and plug them into any existing workflow. A few things to know. So this is day one. CDKs is in alpha. We have big things planned. We'd love for you to collaborate with us and build it with us. We support Python, TypeScript, and JavaScript, as I said earlier. CDKs is built for the entire community. It can work with any cluster that runs anywhere. As I showed you this little sneak peek of CDKs Plus, it's already released very early, as I said. Please come work with us to build it and make it great. Stay tuned. We're going to do some talks and show you a little more about CDK Plus hopefully very soon. And as always, contributions are welcome. Open pull request or an issue, come talk to us. Any type of contribution is celebrated. Thank you very much. My name is Elad. You can find me on Twitter. This is the CDK.io website where you can find all those links. Our GitHub page is also listed there, and Slack channel. Thanks so much for coming. Bye.